So I'm Paul, I'm the CTO of Dark, and I'm here to tell you a story about complexity. So back when I wrote software for Unix, we compiled software in a very simple way. We ran configure, and then we ran make. And the way that this software was written was that we had make files. And the make files described the dependencies of our applications and how to build them when those dependencies changed. And then we had configure files. And configure files were sort of polyfills across all the various different kind of Unixes that were out there. Solaris, and AIX, and the BSDs, and the Linuxes. And a suite of tools built up around these that were called the AutoTools suite to allow people to compile Unix software easier. There was libtool, which allowed us to abstract over shared libraries. There was autoconf, which generated configure files. And there was automake, and you gave automake a description of all the files in your application, and it generated make files in order to allow you to compile them. And the way that we got to this suite of tools was incremental. It started with just make files, and then it built up, and it built up. People fixed bugs, added tools, fixed particular use cases, and at the end of it, we had this complete, mature AutoTools suite, which is a nightmarish hell of complexity. Nobody loves AutoTools. It uses 6 different languages, one of them, M4, that nobody knows, and they use M4 to generate shell, a language that people think they know, but no one actually knows. And the way that we got there is incrementally. We got there in small chunks. Each small chunk that we did was a small positive improvement over what came before. And we ended up with this massive, massive complexity. And we do this a lot in our industry. We do this all the time. Let me talk about Docker. So Docker, when it came out, was this wonderful tool. It solved a lot of things that were really difficult before then. It was lightweight virtualization. It allowed us to package up our entire application into a single container. It allowed us to have dev production parity, and it allowed us to share our tools across our entire dev team. And after Docker came Compose, and after Compose came Swarm. And then came Kubernetes, the big behemoth in the container space. And with Kubernetes, we're building software like Google. We're scaling, we're doing DevOps. We're spinning up clusters, and we're orchestrating fleets of microservices. And then Kubernetes wasn't enough. So now we have service meshes, and API gateways, and container registries, and service discovery. In fact, we have 455 individual tools in the cloud native ecosystem. Cloud native, by the way, a word that means Kubernetes. So it says at the top of this is the Cloud Native Computing Foundation landscape, and it says right at the top, overwhelmed. Are you overwhelmed? Why, yes. Yes, I am indeed overwhelmed, because there's 455 technologies in this slide. How could I not be overwhelmed? What the fuck were they thinking? And I say they, but I actually mean, what the fuck were we thinking? Because this is what we constantly do as an industry. We are incrementalists. We constantly build new and new things, and we never take things away. AWS has 200 services today, and it keeps adding them, and it never takes them away. The last really good innovation in our industry was garbage collection, because garbage collection allowed us to actually remove complexity. Before there was garbage collection, people spent 40% of their time writing code to manually allocate memory. Now, garbage collection was invented in the 60s, and it was eventually popularized in the 90s, which is the kind of fast-moving innovation our industry is known for. There's this essay called No Silver Bullet. No Silver Bullet was written by a guy called Fred Brooks, who wrote The Mythical Man Month. And in it, he talks about accidental complexity and essential complexity. And essential complexity is the essential stuff that you need. It's the stuff that you need to build your product. It's the value that you bring to your customers. It's your differentiation from your competitors. It's the thing that your product does. And accidental complexity is everything else. It's the stuff that you need to do, the stuff that you need to build in order to be able to start doing your essential complexity. It's this. The point of No Silver Bullet was talking about developer productivity. And he said that there was no way that we could get a 10x productivity improvement because that would mean, by definition, removing 90% of what we do. And in order to remove 90% of what we do, 90% of what we do must be accidental complexity. And, he said in 1986, accidental complexity was not 90% of what we do. And today, you need to know Kubernetes, you need to know Docker, you need to know Git, load balancers, dozens of AWS services. You need to know SQL and NoSQL. You need to know Kafka and Unix and GraphQL and gRPC and Thrift and DNS and Memcached. And you need security, and you need optimization, and you need networking, and you need observability. And it just goes on and on and on. And the complexity that we have in building backends today is out of control. It's infrastructure, it's deployment, it's APIs. And Dark is about removing all of this complexity. And I've often struggled to describe what Dark is or what Dark does, because to me, Dark is really just about the absence of this complexity, at the absence of this. So the essential complexity of infrastructure is that you need to receive data, you need to process data, you need to store and query data, and then you need to send data. And you don't need anything else. It just so happens that that's the only way to do it today. So you don't need AWS. You don't need containers and Docker files and service meshes and API gateways. You don't need Kubernetes. It's the same in deployment. We've built up these massive CI/CD pipelines that enable us to deploy code. And I think people are often surprised that I describe this as accidental complexity, because of course we need to get our code from our computers into the cloud, into where our customers can talk to them. But the thing is, how much of this slide is actually important? How much of what we're looking at here is value that our customers can derive, values that our customers can point to? The only essential complexity in deployment is the speed of light. It's the distance between you and your keystroke and the data center. And it seems kind of ridiculous, but we've already separated the act of deployment, which gets our code into production, from using feature flags, which is what we do to actually enable it for our users. And once we've got feature flags, what is the value of this deployment? Well, that deployment is now entirely risk. APIs are hard. They used to not be hard. It used to be I would import a library and then I would call the function by just calling the function. But now my functions are behind complex remote procedure calls with errors and retries and backoffs and rate limiting and auth and serialization, and they're built with disparate formats: GraphQL, gRPC, Thrift, SOAP, REST. APIs have become so complex. And so we come to Dark. Dark is a new programming language with an integrated editor and infrastructure, which we've created to solve this complexity. Before this, I was the founder and CEO of Circle CI. And before that, I did a PhD in compilers and static analysis. I've spent a long time thinking about how to make coding easier and how to make developers more productive. The team and Ellen and I have been working for about 2 years, and we're excited to show you what we're doing, and specifically how we can abstract over all of this complexity to allow us to build backends more easily in the cloud. Ellen has another video that you should watch where she shows you how to create an app in Dark. If you haven't watched that video yet, you should stop now and go watch that video because you'll need it for context for what comes next. So Dark is our solution to all this complexity. We're removing the complexity not by making a small incremental change, but by making a big change. We're building a language that is so totally integrated with its editor and infrastructure that we're able to remove a massive amount of this complexity. So our approach is simple. We wiped the slate clean. We looked at every single piece of complexity in building backends, and we looked at ways to remove them, and we looked at what product could be built that allows us to build backends without this complexity. The result is an abstraction, a language that sits over the cloud, that doesn't require you to worry about infrastructure, and that scales for you. It's a language that has no impedance mismatch between the infrastructure and the language. It's a language with an editor that's designed specifically for it, that prevents common errors, surfaces relevant information, and reduces the complexity of coding. And most importantly, it's a language that's designed to reduce the time it takes to get code to your users, that allows you to deploy in 50 milliseconds, and that does so safely. So I'm going to tell you about the Dark infrastructure and how it removes all of the accidental complexity. I'm going to talk about the editor and the language, and I'm going to talk about the intersection of all three, of the editor, language, and infrastructure, and how it allows deployless, which is what we use to safely deploy code to production in 50 milliseconds. I'm also going to talk about live values and how we can show you real values from production as you edit, which simplifies writing code, reading code, and understanding your code base. So you might recognize this code from a coding interview in 2009. As we look at FizzBuzz, we can see that the important thing here is that Dark is just normal code. It might be a little more declarative than you're used to, it might be a little more functional than you're used to, but it's just normal code. And if we look at a program in Dark, programs are made up of HTTP endpoints. And we can see one here. And we see that we receive data, we send data, we process data, we query it, and we save it. We do the essential complexity of infrastructure, but we do it using normal code. Dark takes care of the infrastructure for you. You don't need to think about anything in infrastructure. We've removed this huge chunk of accidental complexity. What programs in Dark are made up of is the primitives that you're probably used to if you've written backends before. If you've written anything in Rails, if you've written anything in Node or Express or Django, these are the standard primitives. There's data stores, there's scheduled jobs, there's background workers, and there's HTTP endpoints. And this is all you need in Dark, and this is all you should need, because this allows you to read data, to store it, to process it, to query it, and to send it. It allows the essential complexity of infrastructure. So we have a structured editor. And a structured editor means that it doesn't just allow you to write text. It structures the code that you write to prevent errors. So in Dark, you can't write syntax errors. In fact, it's not possible to have a syntax error because there isn't a parser. When you edit code in Dark, every keystroke modifies the AST. The AST is sort of the in-memory representation of your program. You can think of it as equivalent to a DOM. And so we modify the AST as we write code. And I'll show you the video here. And you can see here that it feels textual. It isn't textual, but it feels just like you're writing text. We type a bunch of stuff, and then we hold down backspace, and then we work through all these things. And at every single point through this, there's a valid program in front of us. So the editor is influenced by ParEdit, which is a Lisp editor in Emacs, and by academic tools like Hazel and Sketch, and also by IntelliJ's MPS. And it's similar to Embedder and Tofu.js. So the Dark language itself is this functional imperative hybrid. And it's influenced by languages like Elm, Rust, OCaml, Swift, Ruby on Rails, Clojure, and TypeScript. And when we say functional imperative hybrid, we mean that you still code in a largely imperative way, but that we've taken a lot of influences from functional languages, in particular immutable values, records and enums instead of object orientation and inheritance. We use results and options instead of exceptions and null. And it's garbage collected and has static types. So we actually try not to do too much interesting stuff in the language itself. The language, like the editor and like the infrastructure, is based on many things that people use and have been using for years. We try not to innovate too much in there. We try not to invent too much stuff. Where we do the interesting stuff is at the boundaries of these things, at the boundary between the editor and the language and the infrastructure, the editor and the infrastructure, and in particular at the intersection of all three. We found that most of the innovation that's done in the developer tool industry is at the intersection, but our industry is too full of incrementalists. We spend a lot of time thinking about languages, so people go to design a new language. They go to build a new editor. They go to add a new tool to the stack of infrastructure tools. But when you look at the work by Brett Victor, or you look at what Lighttable has done, or what Eve has done, what they did was they crossed over between editor and language in particular. And the thing is, we've discovered that there's so much low-hanging fruit in these intersections. When we look at the intersection between editors and infrastructure and language, there's so much low-hanging fruit that we implement the most obvious thing, and then it blows people's mind. So an example of this is deployless, which is what we call it, where we deploy code in Dark in 50 milliseconds. And we're a little sheepish about the term. We didn't coin it. It was coined by Jess Frizzelli about Dark. And in deployless, there's a deploy, just like there are servers in serverless. But just like serverless means that you don't have to think about servers, deployless means that you don't have to think about deploys. And the things that we think are super important about deployless are these three properties. One, it's an instant deploy. Two, there's no deploy step. So just because it's an instant deploy, it doesn't work if you have to do a save or if you have some deployment process. It has to be that you write code and it is deployed already. And the thing is, we used to write code like this. Back in the 90s and 2000s, when we were writing PHP code on shared servers, we had this glorious feeling of immediate feedback from when we wrote code. But it wasn't safe. It wasn't safe to write this code because you'd be editing something and you'd cause a parse error and users were still trying to use your website. So the third and most important part of deployless is that it's safe to make changes. And I'm going to show you how we do that in Dark. So we use feature flags as our workhorse for how we enable simple deployment while keeping programs safe. So let's walk through what feature flags look like. So this is a part of Ellen's demo. In Ellen's demo, when you made a request to visit, it sent background workers to send a text and to send a Slack message. So let's add to that. Let's support sending an email as well. So we take the program that we had, and then we add a feature flag to it. So what I'm doing here is I'm selecting the code, I'm using the add feature flag command, and you can see our documentation for the command at the start there. So we add a feature flag, and now we have our code that we're changing wrapped in a feature flag. And that feature flag forms a sandbox. Because our condition isn't filled in yet, everyone sees the old code. Every request that comes in executes the old code. So that allows us to build this code in complete safety because no one is executing the code that we're writing. So we start by writing the new code. And maybe we get it right, maybe we get it wrong, but we have code to emit to the send email handler, and then we can go and write the send email handler because no one is calling that. When we're done with this, it's time to enable it. So we start by adding the feature flag name, which is equivalent to a branch name in Git, and then we add a condition. Now typically you'd add a condition like if the username is my username, so that you can just enable it for yourself. Or maybe it would be something like if the users are in the beta test. But we don't have users in this particular piece of code, so we're just going to use a HTTP header. So if the send email HTTP header is set, then we're going to do our new code. And of course, our client doesn't have that set. We're just going to enable that in our client so that only us can see the new code. So we test it. We see that it's ready to go out. And then, now that I've got my feature, I want my colleague to review it. So they can enable it for themselves in the condition as they go to do the code review. Or If you want to loop in others, this whole thing is visible to your whole team. So maybe the PM wants to try it out, or maybe the QA team wants to do a pass on it. They can enable the flag for themselves so that they can see how it works. And then once it comes time to enable for all your users, you increase the percentage of people who see it. And then once you've got your confidence up, you finish by setting it to 100% and by closing the feature flag. And we're done. The whole feature is done, and it was safe the entire time. So in the future, this is where we're going to add unit tests. This is where we're going to add functional tests. Today, you can already use browser-based integration tests. This is also where we're going to put our version control. You can undo today, but we want each of these feature flags to be equivalent to a branch that you can go back to in your history, just like it is in Git. So if we go back to our CI/CD slide, we go back and see how much of this complexity of this deployment mattered. Well, we've gotten rid of this Kubernetes section. We've gotten rid of this whole merge to master middle section, and we've gotten rid of most of the left section. What we've got left is the essential stuff that you need. The actually making the change, the integration tests and the code review, and then the slowly rolling it out to users. And each of those slow rollout is one single command in the editor in Dark. And the reason that we've managed to condense so much stuff here is that we've combined multiple concepts. Because today, in how people write code today, there's 3 different ways of shipping software. There's our Git way of doing it, that we merge it into master. There's our deployment, where we get the code and we put it onto the server. And then there's the feature flag, where we actually enable it to users. And this is the sort of incrementalism that I'm talking about, because we added 2 new ways to deploy software without taking any of the old ones away. So feature flags solve quite a lot of how we do deployless, but we also need to change how we change our software. In Dark, we don't change anything. Anytime you want to change a function, what we actually do is we create a new function, and then we stop using the old function. So in our standard library, anytime that we've made a change to a function in Dark, anytime that we've made a bug fix or we've changed the signature, what we've actually done is made a new version and then deprecated the old version. Users who are using the old deprecated version can continue to do so until they decide it's time to change. And users who come along later never need to know that there was ever a deprecated function in the first place. And we use this versioning to ensure that the software never changes out from under you. Because the way that we write software today, it's very difficult to tell what can change. If you think about upgrading the packages in our applications, every time we upgrade a package in our application, we also update the transitive dependencies of that package, which can change how a completely different package works. It's impossible for us today to reason about a single small change that we make to our system and know that the change that it does is completely safe. But when we version everything, and in Dark, we've already versioned the standard library, we're versioning all functions, we're versioning types, and we're even versioning the language and our data store migrations. When we do this, it means that users can go through every single change and know that they're making it individually and test out the changes individually. And of course, we'll have tooling to make this fast if people want to go fast. So one of the features I'm most excited about in Dark is what we call live values. And it's one of these things that we get from being the intersection of language, editor, and infrastructure. So a live value in Dark is where you can click anywhere in a Dark program and see a real value that has passed through that program recently. And we do this by saving every trace that comes through our application. Every request that's made to Dark infrastructure is saved so that you can play it back later. And we put our execution engine inside the editor so that as you write code, we'll update the values that you're seeing. So you can kind of think of this as a debugger. And typically, there's 2 kinds of debuggers. There's one where you stop the world and where you can step through the whole program. And then the other one, which is print statements, where you judiciously place print statements in your program and you use the logs to figure out what happened. And the advantage of the print statements is that you don't have this big heavyweight process. But the disadvantage of it is that you need about 20 years of experience to actually figure out where to put the print statements. In Dark, we get the best of both worlds. You don't have to do any work to get live values in Dark. They're done automatically for you, but you can still see them at any point in the program. And in fact, you can do it completely post hoc. You don't have to do anything to start a debugger. You don't have to insert print statements. You don't even have to be aware of the event at the time that it happened. You can go back to any event in the past and step your whole way through it without a problem. Live values enable us to understand programs. It's so easy to look at a piece of code that you've never seen before in Dark, and within moments, you can understand what that whole piece of code does. If you see a variable that's called user, is it a username? Is it a user ID? Is it a user's email address? Is it a user object? Is it a serialized version of a user's object? Well, it's hard to tell sometimes, but in Dark, you see it immediately, and you never have to wonder. It also makes it easier to learn. We've been teaching Dark to people who have 2 years experience, and 5 years experience, and 10 years experience, and in some cases, people who have no experience. And after an hour, they're proficient in Dark, and one of the reasons for this is that any time that they're wondering, what does this thing do, they have a live value right there to tell them what it does. Not only does it make it easier to learn, but it also changes how we write software. And you saw this in Ellen's demo with what we're calling the Dark flow. So you write code on your front end, you make a request, that request is received by Dark and is used in your editor to write the subsequent back-end code. You've got the actual requests that your users make available to you as you write code, showing you the results of the computation as you write that code. So Dark is wonderful, and it supports a lot of use cases today. We have a bunch of users who are writing real applications that their users are loving. But there's some things that Dark still needs to get around to. And one of them is scalability. Today, if you use Dark, we can support you to tens of thousands of users, but not hundreds of thousands or tens of millions of users. We have a plan in the future where we're going to use the fact that we have all this information. We have this traffic, we have your data, we have your code, and we can use that to compile the right infrastructure for your application, the right single-tenant distributed system that is for your application. So today in Dark, we have a bit of a canvas metaphor going on in terms of how we lay out code. And we like this, but we found that it can be a challenge sometimes to have really large canvases and really large applications. So we're exploring different ways to allow larger teams to be able to organize their code and to understand the architecture of their applications. We also plan to allow developers in Dark to be able to share their packages with other Dark developers using a package manager. We are keen to explore the intersection of infrastructure and editor and language and the package manager to be able to share much more than is shared today. It's really important to us that Dark is accessible for everybody, which it isn't today. We plan to solve this before our general release. So we haven't solved everything. We haven't solved every piece of accidental complexity that we intend to remove. We're taking a lean approach to building Dark, and we've made some compromises, some hacks, and frankly, some things that we're not especially proud of. But today with Dark, you can create backends in a radically simpler way with no infrastructure work and no deployment complexity. So we showed you the language and the editor and the infrastructure and all the cool stuff we get from the intersection of all three, the deploylessness and the live values. Dark is moving today from our private alpha to private beta. And that means that we're ready to show Dark and to let more people in. So if you've got a backend that you need to build for a web or mobile front end, if you need to build an internal tool for your company, or if you need to build a new HTTP-based service for a service-based architecture, then Dark is a tool that allows you to do that. We're really excited to show you what we're launching, and we really appreciate your support. Thank you.